Hello, and we're going to start section 3.6 today on compound inequalities. Now, this might be some new information, so please take good notes and watch this carefully. So first things first, let's talk about a compound inequality. A compound inequality is two inequalities joined by the word and the word or. Okay? Just like a compound word is made up of two words, for example, bookmark. Bookmark is made up of two words, book and mark. Compound inequalities are two inequalities made into one. So right down here I have the inequality 5 is less than x, which is less than 7. This is an example of an and inequality. There's two types. There's an and there's an or. What this is saying right here is this is the union of the graphs x is greater than 5 and x is less than 7. And now notice that it's the union, it's the joining of two of them. X is greater than 5 and x is less than 7. Hence, this is the reason why it's an and inequality. So we're going to talk more about these inequalities. But first things first, let's deal with writing compound inequalities from words. So, I'm given the situation all real numbers greater than -2 but less than 9. So, we start out by doing the first part. It says all real numbers, so I'm going to represent that with the variable x, greater than -2. So I'm going to write that, graph that. So here's -2, and x is greater than -2. So I'm going to graph everything that's greater than it. So that's everything to the right. Let's choose another color. Let's choose red. But the other part of this says less than 9. So it's all real numbers greater than -2, but less than 9. So therefore, the restrictions on x have to be less than 9. So if I graph that, here's 9, and this is an open circle as well. And it's everything less than it, so it's everything to the left. So the graph of this, it's the parts where they overlap. So that's everything in between -2 and 9, non-inclusive, not including -2 or 9. And we write this as x, -2, 9. So it says -2 is less than x, which is less than 9. So x is greater than -2, and x is less than 9. And so the graph of the two is the union of both of these. If it helps, we'll erase the two originals, and there you go. So try these two on your own. Write a compound inequality that represents each situation. So all real numbers that are at most 5 and at least -3. So here's x, and it's at most 5. Meaning, can it be 5? Yeah, that's the most it can be. So since it's at most, it's everything smaller than 5, and it's included. So it's x is less than or equal to 5. But the least it can be is -3. So x has to be greater than -3, or at least -3. So it's x is greater than or equal to -3. So in my graph, it's going to be -3, 5, and since they're equal to in the inequalities, the circles are filled in. There's everything in between there. Today's temperature will be higher than 64 degrees, but not as high as 73 degrees. So since it's going to be higher than 64, it means it can be 65, 66, 66.5. It means x is going to be greater than it. Can it be 64? Well, no, because it's got to be higher than it. But it's not going to go as high as 73. So the highest it's going to get is just under 73. So it's everything under that. So it's everything in between 64 and 73. So here's 64. Here's 73. And it's everything in between. And they're open circles because they're less than. They are not less than or equal to, so they're not filled in. All right, so the graph of a compound inequality with the word and contains the overlap of the graphs of the two inequalities that form the compound inequality. So here's an example. I have the graph x is greater than or equal to 3 and x is less than or equal to 7. So the graph for x is greater than or equal to 3 goes all the way to the right, and it's a filled-in circle at 3. X less than or equal to 7 is a closed circle on 7 and everything to the left. So just like I showed in the previous example, these ones are showing each individual graph and then the compound inequality graph of itself. And all the problems that we've worked with are and inequalities, the ones that we just saw in the previous slides. So x is greater than or equal to 3 and x is less than or equal to 7. So it's the parts where they overlap. The keyword there is overlap. And you can tell by the dotted lines going down from the base of their restrictions, and it's everything in between. Now down here it says you can only write and inequalities as a single inequality. You cannot write ors. So my compound inequality is x is greater than or equal to 3 and x is less than or equal to 7. So to write that as a compound inequality, since I know x is greater than or equal to 3 and x is less than or equal to 7, I combine them into one inequality. So that's an and inequality written as a single one. Now, the graph of a compound inequality with the word or contains each graph of the two inequalities that form the compound inequality. For an and inequality over here, the solution has to satisfy both x is greater than or equal to 3 and x is less than or equal to 7. It has to be true for both of these. For an or inequality, it has to satisfy one or the other. It has to either satisfy x is less than -2 or x is greater than or equal to 1. It has to be true for one of them, not both. And it can't be true for both because notice how they don't overlap. So there's nothing that's going to make both of these true. So either your solution is going to make x is less than -2 true, or x is greater than or equal to 1 true. And this is what the graph of it looks like. Now notice the and inequality is where they overlap. The or inequalities are going in opposite directions. And you might ask yourself, well, can't I write an or inequality as a compound inequality as just a single one? And some people might tell you yes, but that is not proper notation. So right here I have x is less than -2 and x is greater than or equal to 1. Since it can't satisfy both of these at the same time, I don't write or inequalities like this. That's not proper notation. There's nothing that can satisfy both of these two. There are many values that can satisfy this one, but there's nothing that can satisfy both of them. So here's a little chart that shows the compound inequalities in two forms, and or. So solutions for and inequalities. Solutions make both inequalities true, and you can solve it by writing as two inequalities. You can also solve it by writing as one, but you could also do it as two, and I'll show you what that means. For or inequalities, solutions that make one or the other inequality true. There's nothing that can make both of them true. And then you have to solve the two inequalities separately. So let's try and solve some and inequalities together. So right now I have a single inequality. I'm going to solve it as one sole inequality. I'm not going to separate it as two. So -3 is less than x plus 2, which is less than 5. So to solve this, I have to get x all by itself, just like in an equation or any of the inequalities we've worked with before. X has to be all by itself. But right now I have x plus 2, so I have to get rid of that 2. So I do the inverse operation. Since it's plus 2, I have to subtract 2 from everything. So 2 minus 2 will just give me x. I'm left with x. Now let's go to the right side. I have 5 minus 2, and that's 3. And then on the left side, I have -3 minus 2, which is -5. So the restrictions on my variable x is that it has to be greater than -5 or less than 3. And to check to see if this is true, choose a value from these restrictions and see if it works in your original problem. So for example, 0. 0 is greater than -5 but less than 3. So if I plug 0 into this inequality up here, I get 0 plus 2, and that's 2. So therefore, 2 does fall between -3 and 5, so 0 makes this inequality true. So then we come and graph the inequality. It's open circles. It's everything in between them, because it's an and inequality. All right, try these two on your own. So for this sake, I'm going to separate it into 2, just so you can see what I meant. So I can separate this into 1 is greater than x minus 7, and I can write this as x minus 7 is greater than or equal to -5. I separated them into 2. Now, to solve it, I'm going to add 7 to both sides, and I get x is greater than or equal to 2. Over here, I have 1 is greater than x minus 7, so I'm going to add 7 to both sides. And I get x is less than 8. And it's okay that if one of the signs is greater than or equal to, and the other one's just greater than. It's okay if one is equal and one's not. So now I graph this, and I get 2, 8, open circle, close circle, it's everything in between. All right, so let's look at this one. 7 is less than -3n plus 1, which is less than or equal to -2. First things first, I'm going to subtract 1 from both sides. I'm left with -3n, less than or equal to -3. 6. Then I'm going to divide everything by -3, but be careful because now I'm dividing by a negative. All the signs are going to flip. So it's greater than or equal to 1, and is less than 2. So the reason why I did this one here is because, notice, it's n is less than -2, but is greater than or equal to 1. This here is not an and. This is going to be an or. N is greater than or equal to 1, or n is less than -2. So if I have to graph this one, here's 1, here's -2, open, this is closed, and is greater than 1, and is less than -2. This is an and problem, this is an or problem. Let's try some more or ones, okay? So I have 4 plus x is greater than 3, or 6x is less than -30. So I'm going to divide both sides by 6 over here, and I get x is less than -5. Over here, I'm going to subtract 4, and I get x is greater than -1. So the restrictions on this one are x are less than -5, or x is greater than -1. So here's -1, here is -5, x is less than -5, this goes that way, x is greater than -1, so it goes that way. Try these two on your own. So over here, I'm going to divide everything by -3. I get n is greater than 3. Over here, I have divide by -2. I get n is less than -5. So it's n is greater than 3, or n is less than -5. Come and graph this. Here's 3. Here's -5. Open circles. N is greater than 3, so it's everything to the right. N is less than -5, so it's everything to the left. 5y plus 7 is less than or equal to -3. I'm going to subtract 7 from both sides. I get 5y is less than or equal to -10. Divide both sides by 5. Y is less than or equal to -2. Or my second inequality, I'm going to add 2 to both sides, and I get 3y is greater than or equal to 15. Divide both sides by 3. y is greater than or equal to 5. So I'm going to graph this one, -2, 5, closed circle, shade to the right, open circle, shade to the left. Interval notation, this is important. So you can use any inequality such as x is less than or equal to -3 to describe a portion of the number line called an interval. You can also use interval notation to describe an interval on the number line. So here we go. Interval notation includes use of these three special symbols. And these symbols include parentheses. So when you have to do interval notation, and I'll show you what that means. You use parentheses when it's a less than or greater than symbol to indicate an interval's endpoints that are not included. For example, if I had x greater than 3, I would use if I had x is greater than 3, since 3 is my minimum, I'm going to use a parenthesis to show the end of that, and then it goes on forever, so it goes to infinity. And that's what's down here. We use infinity when the interval continues forever in a positive direction. We use negative infinity when the interval continues forever in a negative direction. So if I had x is less than -5, the interval notation for this will be, well, the minimum is going to be in negative infinity because everything's smaller than -5. But the largest it can be is -5. Then brackets. We use brackets when it's less than or equal to or greater than or equal to. So if I have x is greater than or equal to 2, so my minimum is going to be 2, my maximum is going to be infinity. If I had x is less than or equal to -8, my minimum is going to be negative infinity, my maximum is going to be -8. So here's some examples. Here's x is greater than or equal to 2. It's a closed circle, everything to the right. 2 is your minimum. There's infinity. X is less than 2. So it's an open circle on 2. It's everything less than it. So it's from negative infinity to positive 2. But since it's less than, it's going to be parentheses. For an and, 1 is less than x, which is less than or equal to 5. You can have both. So it's an open circle on 1, it's a closed circle on 5, so it's everything in between 1 and 5. So that's where the interval comes in. It's everything between 1 and 5. 1 is not included, but 5 is. So it's a bracket at the end and a parenthesis around 1, because 1 is not included. Then for an or, when they go in different directions, this is the important part. It goes from negative infinity all the way up to -3, not included. So we use parentheses over here for the interval notation. And then there's the little margin where we skip. So because it's an or problem, we write or. And then it's a closed circle on 4 because x is greater than or equal to 4. So it's a closed bracket, an open bracket, 4, and continues on forever, for infinity, close bracket. So write the interval notation of each graph and write the inequality of each graph. Try this one right now. So the interval for this one is -2 to 5, and it's x is greater than -2, less than or equal to 5. For this one, it's negative infinity to 3, and it's a closed bracket, or bracket 8 to positive infinity. And we write this one as x is less than 3, or x is greater than 8. This one's -4, -1. We write this as x is greater than -4, x is less than -1. And down at the bottom, it's negative infinity to -3, bracket or parenthesis 5 to positive infinity. And this is x is less than negative 3 or x is greater than 5. What is the graph of negative 3 to 2? How do you write it as an inequality? So if I was to graph this, here's my number line. All right, negative 3, all right, positive 2. Since it's a parenthesis, I know it's going to be an open circle over here, and since this one's a bracket, it's going to be a filled in circle right here, and it's everything between negative 3 to 2. So it's going to be everything in between there, and I write this as x is greater than negative 3, but it's less than or equal to 2. Try this one on your own. Write the graph of negative infinity to negative 1 or 2 to infinity, and write this interval as an inequality. So I know it goes to negative 1, and I know it goes to positive 2. Since it's a closed bracket on negative 1, it's going to be a closed circle, and it's everything to the left. Over here, it's an open circle, and it's everything to the right. And x is less than or equal to negative 1, or x is greater than 2. And that's the video. Yes, it was a long one, but I hope you got a lot of valuable information out of this. I will see you tomorrow, and don't forget to take the quiz.